Salute, this is Jeff. This is a devlog for the house streams along with them. Let's get a Unreal Engine 5.3 game running on a Steam Deck at 60 frames a second. Is this possible? Yes, it is possible. It's going to require some effort, though. There's a number of optimizations that I've done and many more that will come, but I'm going to provide a helpful list of 12. Actually recorded a video of the Steam Deck without the optimizations, which you can look at here. Steam Deck videos folder and exterior.mp4. Yep, there we go. As we can see, it is not moving very fast. Fortunately, we have a way to fix this. Let's start with custom scalability settings. Wherever you have the engine installed, there's going to be in this case, 5.3 is the version I'm using. We're going to the engine config. There's going to be a base scalability INI file. This will define the CVARs, that is to say the console variables, that are applied when the engine scalability settings are set between 0, 1, 2, and 3, which is typically low, medium, high, epic. This is where the defaults are defined for the engine, which will then be imported into the game as well once you build it. So I've made some tweaks here, mostly because the most intense scene, which is the one we have going on in the background here, which has some trees, grass, so we've got foliage system, we've got blowing in the breeze and things like that. I wanted the grass to still be there, even if we load in here. We set the scalability settings of the foliage all the way down. Go to the individual quality for foliage. As you can see, it removes many of the trees and almost all of the grass, but not all of the grass. By default, the engine scalability system will, on low settings, completely remove the grass. I wanted there to be some grass, even though, you know, it's perhaps there's been a bit of a drought, you know, since the last time someone opened the menu. But so it goes. As an example, one of the tweaks I've made for my particular game, the foliage and grass density scales by default were like 0. But I wanted to keep a little bit more of that. So this is an example of something that can be changed in the scalability settings at the engine level. Number 2 is actually the same as number 1. We just did that one. Number 3, reduce maximum texture sizes. Look at the black adler trees. Alder, not adler. Alder. This is not a former drummer of Lamb of God. This is a tree. This is the foliage version, which we have a reference to the mesh. Let's open that up. You can see that we have a bunch of different materials that have come in. One of the things I want to try and do here is go into, let's use the trunk as the main example. Get up there. Back to the extension. Double click on the material instance here. We can see the actual input textures here. We've got the black alder, trunk, albedo, mass normals, etc., etc. But for the sake of this particular, we're just going to look at the albedo. We have here, it's taking us over to the content browser, and we have, double click on this. This originally comes in at something, yes, it imports at 8K, which is ridiculous. Also, people can't afford RAM anymore, so best to knock this down, not just for performance reasons, but also so that the GPUs that are running the game are not going to explode into balls of disturbing plasma while trying to just load simple things like a tree trunk. Fortunately, right here in the compression settings, we've limited it to 2K. And you can apply these settings to multiple textures at once by using the asset actions property matrix, which will give you everything you've selected in a fun little list here. Search for max here. We got max texture size. All 3 of these have the same value, which is why it shows up here, but this can be used to bulk edit lots of things. Remember to save beforehand in case you bulk edit 600 textures and the engine crashes after changing 400 of them. As a random example of something might happen, how would I know? I don't know. I'm an oracle occasionally. Another thing we can do is reduce the nanite triangle percent. Let's go into one of the trees that is being used in the foliage system back here. We'll click over here. Nanite and Lumen are being used in this project, although Lumen is being disabled for lower end hardware. Nanite is still being used, so for very, very busy trees like this, you can just reduce the triangle percent. So this particular LAD has been reduced 33%. Another thing that you can do here, specific screen sizes for each LOD or LOD, level of detail fallback. And you can also set a minimum LOD, which you can, let's see, minimum should be in an option here. Minimum, how do you spell words? Yeah, there we go. Minimum LOD is 4. Fallback, LOD 4, LOD 5, and LOD 6, which is just the the hilarious windshield smearing of the platonic idea of a tree, which works just fine. When importing these mega scan trees, use the Simple Wind versions. There is a Pivot Painter and a Simple Wind version. I think that the main difference is the complexity of the shader and the WPO, which stands for the world position offset that's being calculated. This is a simpler and more efficient, algorithm shader cost. I'm not a shader designer, so I don't know the specifics of it, but just comparing the numbers, it is much more performant to use the Simple Wind. Would recommend doing that, especially if targeting older hardware. Another thing you do is disable the WPO, which stands for World Position Offset, at a short distance. Per static mesh, these things can also be set for the foliage version of the tree. One of the things we can define here is to have a disable distance for the World Position Offset, which means that after 1,000, in this case centimeters, away, the tree will stop moving. Next thing to do, especially with trees and grass, disable shadow casting and small grass, shrubs, and so forth. Actually, let's put the foliage back up so we can get the full... Yeah, there we go. Full coverage of grass and trees with some of the grass is blowing in the breeze using the world position offset, but not all of them. Another simple reduction here, like these adorable little flowers here are not blowing in the breeze. And almost all of the grass and items on the ground there are not casting shadows at all. We just have the large trees and the larger sort of shrubs also casting shadows. Everything else has been disabled. Another thing we can do is disable shadow casting on far away trees. I've made a separate foliage type for distant trees, which are dotted along the edge of the way back in the mountains, essentially, that is distant from the player. And this is way outside the playable area. So if you're just hanging out in the normal game world here, if you know what you're looking for, you could zoom in on the background and see where. Oh, that's the. There we go. Let's do a FOV zoom in here, and you could zoom in, and you could notice that okay, there's a little crustiness off in the distance, but so it goes. The next thing you need to do, the most important thing is reducing the attenuation on your lights. That's basically it. You can use the optimization view mode light complexity to get an idea about where the most overlaps of lights are. Okay, we've got a lot of lights going on here in the kitchen area. Disable the fluorescent lights here. We can see the difference it'll make in the complexity graph. And let's grab that one too. Okay, let's just hide them. Hide them as an example. You can see, we've got colors back in this particular view. But this has already been optimized to my liking. You could always tweak some more. So I'm going to Control H in order to bring the lights back. Press G to go into game mode, get rid of all the extra lines. Although there are 4 lights really close together here, there are some extra optimizations we can do to make it even easier on the older hardware that we're targeting with like the Steam Deck. One of the things that we can do is to change whether or not a light even casts shadows at all. Let's filter the outliner into lights only. Rectangular light in the master bedroom. Press F to zoom into it. We disable shadow casting. You can see that it bleeds through the wall, but this actually might be perfectly fine. This does mean that it is easier to calculate, so you'll get like tiny little bits of frame rate back. But going through each individual light and deciding whether or not this actually needs to cast a shadow or not is an important part of just making everything run smoother, especially with where lighting and shadowing, at least in my experience, has been the largest bottleneck for performance, especially on this game that I'm working on now. Even though it's a puzzle game, it's first person and has realistic-ish visuals, so the fidelity and the lighting and the bounce lighting and like the global illumination, all of that is like an important part of the experience. Now let us get into some optimizations that are very specific to my particular game, but hopefully, you can take something from it, adapt it into your own games. This is all done in blueprints, so we'll be looking at the blueprints of a custom visibility trigger system which I developed. What does that do? Well, to put it simply, if we go to the viewport here, we have technically this little trick box is the only important part. Affected actors box was a earlier design which is unused at the moment. Please ignore. Trigger box here is simply going to tell if our main character, our pawn, has moved in or out of the box. And what is that going to do? Well, we're going to have a list of affected actors that we set dynamically. Not dynamic, well, technically you could set it dynamically, but in this case it's set specifically in the design phase here in the level. In the pantry we have a single light here which is being defined as the custom actor that this is looking for. In the set custom visibility trigger box specifically is what I'm referencing here. Let's go back to this. Let's lock it so that it doesn't go away. This is going to send, so when our pawn walks into the trigger box or out of the trigger box, it's going to send a signal. In this case, the signal is a interface event call. In the interface, the blueprint interface for interactables, which I have that affects things in the game that are interactable. Stuff you can click on, twist, tinker with. One of the events or functions here that is on all of those that implement all of the actors that implement the interface called interactable has custom visibility, which can be set customizably, a real word, in each of the individual actors. For light actors, or actors that are derived from the light parent class, which I'm going to search for over here. The light parent is the parent of many, but not all lights that I have in the game, especially ones that are interactable. The class settings here, it by definition, it and all of its children have the interfaces of conditional trigger, interactable, and savable. Conditional trigger is specific to what I needed to do for some other stuff, but interactable and savable should be pretty self-explanatory. These are the functions that make them interactable. And in the interfaces side of the graph over here in the My Blueprint section, we can see where all of the interface specific logic is. If we double click on set custom visibility, we can see that this is what light parents and light children, naturally, are being told to do. They're checking for a few specific tags using actor tags. About no custom visibility means it's going to skip this check entirely. Custom visibility shadow casting means that it's going to change the behavior. So the default behavior is to disable the light at a certain distance. So the light is just not casting at all. By using the tag custom visibility shadow casting, instead of disabling the light after you get to a certain distance, it will change the point light here, instead of casting shadows here, to not casting shadows at all. So the light will bleed through the walls, but the computation for the light will be much, much easier on the CPU, the GPU. The computer will love you. Again, it won't melt down. If you're playing in the middle of summer, like I am, then it won't just be another heater heating up your room. In here, this is the single light which is in the pantry, which is defined by an invisible box which is around it, which when I get far enough away, for a safe example, if I hide in the corner here, we can see this is the moment when the light turns off. Turns on, turns off. We can also see an example of the shadow casting variant coming in from the music room right here. So you can see in the distance, in the middle of the screen here, we have light shining into the sort of roof area. We move a little bit closer. As our character moves into the custom visibility trigger, it looks like the light is turned off. What that actually means is that the light has shadow casting applied so that it is actually it's catching the walls and ceiling. It's not going through the walls and ceiling. So all of these lights can be assigned arbitrarily to all number of different visibility trigger boxes, and I've scattered those all around the house so that the different angles, they can be individually tweaked. But even past that, I have defined a separate visibility style for the Steam Deck itself. So if we apply the Steam Deck preset, let's reload, let's go inside. We'll notice that for the Steam Deck preset, there's a lot more lights, or many more of the lights have their shadow casting disabled. For example, if we look here, there is no shadow under this chair because this particular light does not cast any shadows, but it is not universally turned off. So where appropriate, I've picked specific lights in the house that I think make the most sense, the most dramatic shadow casting. So like the chandelier here over the dining room table still casts a shadow, even on the Steam Deck settings. The last specific optimization I have today is dynamic resolution. What is dynamic resolution? It's where the resolution is changed dynamically. Shocking. When you're exporting to consoles, dynamic resolution is a feature of the engine, which I have no access to because I'm making a game for PC, and dynamic resolution does not work on PC for Unreal, but with blueprints. Now, you could, of course, make your own in C++ if you download the engine and you're a software engineer that knows C++. More power to you. I am, however, a lowly solo developer idiot that's working only in the language that I know, which is pretty pictures made of fun, colorful lines. So, by using pretty pictures of fun, colorful lines called blueprints, we can simulate a dynamic resolution system. I have made my own custom little events and functions that I've put onto my player controller. In this case, it is using the delta time of each frame as a goal. Fun little reminder here. If a frame takes 16.66666 milliseconds, you're running it at 60 frames a second. 8.3, that's 120, 6.94, that's 144, 4.16, that's 240. But this kind of thing can be defined dynamically. Just take the seconds, multiply by 1,000, then you've got your frame time in milliseconds. Another way, this is just some basic math here. So we're taking the delta seconds, we're converting it into a frame time. It's using the frame rate limit, which is defined in the video settings as our maximum. So let's say we're looking for, in the case of the Steam Deck preset, we're looking for 60 frames per second, which is 16.6 milliseconds frame time as our goal. We have that going less or more than the target for a certain amount of time. In this case, the dynamic resolution is updating every second rather than every frame. Although the frame data is being updated every frame, the actual ticks of the dynamic resolution is only like every second. So I've defined here that after a number of ticks, in this case, custom ticks is a few seconds, if it has consistently been over the limit of the frame time that is desired. So we actually need to reduce the resolution to try and get back to it. If there's 0, that means there's no change. And then 1 in this case means that the frame time is lower. So it might be possible to boost the dynamic resolution back up to its maximum. In this case, the maximum is defined by the preset. The Steam Deck preset is a 66% screen resolution maximum, and the minimum is half of that. So it is dynamically switching between 33, which is really low, and 66, which is reasonable on the handheld screen. And it's doing this by changing the screen percentage console variable event here that will just do it for me, that I set up, which is this is the equivalent of pulling down the console and doing screen percentage space and then an integer between 0 and 100. In this case, the float value is being converted into an int, and then it's being put into the string, which is executing a console command. And this is only happening if the dynamic resolution is set to on in the options, which, as part of the Steam Deck preset, it is. So anti-aliasing. Dynamic resolution is off. Let's also define our goal of let's say 90. So let us turn on and hope that everything works. Okay. We see that our frame rate is ticking up, and the the screen is getting more mushy as the screen resolution is lowering in order to try and hit the target frame rate. That is all for this devlog. Hope you learned something about optimization, practical optimization. I am no expert, but I am trying to actually release a product here. So these are things that I found that are practical. Things that have made a demonstrable difference in the actual performance, especially on the low-end hardware that I'm targeting, which again is running at 1280 by 800 resolution on a Steam Deck at 60 frames a second, or as close as possible for most of the game. Because I also do hopefully want to get the game sort of Steam Deck verified. And this will be this is the process that I've gone through in order to get the most sort of light and shadow dense part of the game running at an acceptable level. Hopefully it's inspired you. If you see something I did here that you're like, oh, I didn't know I could do that, you can do that. If you see something I've done here and you're like, oh, that's the wrong way, you should never do it that way, then that still counts as inspiration. Good luck making your own video games.